The Panama Canal stands as one of those monuments that not only tell the story of engineering, but also of human stubbornness in the face of the impossible. It is an open scar in the heart of the American continent, a monumental artery that links the Atlantic to the Pacific through a system of locks so precise and sophisticated that it seems to defy logic. These gigantic water chambers function like colossal elevators, capable of lifting true mountains of steel, ships weighing more than 53,000 tons, up to 26 meters above sea level. Each operation moves volumes of water that are difficult to even imagine, around 200 million liters, shifting in just a matter of minutes. It is such a demanding process that it turns water management into a strategic, almost surgical mission to prevent the resource from being consumed faster than nature can replenish it. And so the inevitable question arises, the one anyone would ask when witnessing such a spectacle. How do they manage to lift a ship the size of a horizontal skyscraper? What invisible machinery sustains this perfect choreography? In this video, we're going to dive into the heart of the Panama Canal, accompanying a vessel on its full journey to understand how the mechanism that forever changed the history of global trade actually works. For centuries, the only option to cross from one ocean to the other was to sail around the southern tip of the continent, facing storms, weeks of additional navigation, and one of the most dangerous maritime passages on the planet. Everything changed in 1914 when the gates opened on one of the most ambitious engineering projects ever undertaken. A project many considered madness, but which today, after more than 1 million completed transits, has become one of the logistical pillars of the modern world. The dream of connecting both oceans through a waterway was not born in the 20th century. It had been circling the minds of explorers, engineers, and rulers for more than 500 years. It was a tempting promise to shorten by nearly 20,000 kilometers a journey that consumed weeks, lives, and entire fortunes. What once required close to 2 weeks of detouring is now resolved in just 8 hours. 8 hours that have turned the legendary Cape Horn into a reminder of another era. The canal is not only faster, it is nearly 40 times more efficient in terms of time. Each year, roughly 14,000 ships travel its 80-kilometer length, transporting 172 million tons of cargo that traverse the continent in a single day. That constant dance of goods turns the canal into a gigantic economic engine. Toll collection alone exceeds $2 billion annually. Some of the largest vessels pay over $500,000 for a single transit, a figure that sounds exaggerated until you understand the time and fuel saved. Now let's picture the protagonist of our story, a colossal container ship making its way from Limon Bay on the Caribbean coast. It has spent 3.5 weeks navigating open sea from Israel, with its final destination in China. It crossed the entire Atlantic in search of a route that would let it pass from the Caribbean to the Pacific without losing nearly a month detouring around South America. To put it in perspective, traveling from New York to Los Angeles using the canal takes about 10 days. Doing it by circumnavigating the continent would take around 24. Those 14 days of difference in the logistics world translate into money, contracts, and opportunities gained or lost. More than 100 years after its inauguration, the Panama Canal not only remains relevant, but stands among the most important infrastructures on the planet. Reaching Panama City on the Pacific coast requires navigating extremely narrow passages and lock chambers that seem tiny compared to the titanic mass of Panamax vessels. Ships built exactly at the limit of what the canal's original dimensions allow, reaching 53,000 tons and practically filling every centimeter of the lock. The crossing must take place within a strict time frame, 8 exact hours, always before nightfall. Due to the level of precision required, the ship's captain cannot command the maneuver. Unlike other ports around the world, here it is mandatory to hand over full control of the vessel to a specialized canal pilot, a professional who knows every curve, every current, and every centimeter of this waterway as if it were the palm of his hand. Today, we're accompanied by one with more than 16 years of experience, supported by a second pilot who is essential when dealing with gigantic vessels. Being a canal pilot is not a profession taken lightly. It requires around 8 years of intensive training, a blend of technical knowledge, advanced navigation, and almost surgical mental precision. Each day, about 36 vessels traverse the route in both directions, moving nearly 500,000 tons of cargo. There is no room for error. Entering from the Atlantic, the ship faces its first test: 3 consecutive locks that will gradually lift it to the 26-meter elevation of Gatun Lake. Once across this artificial lake, one of the most strategically important on the planet, a series of twin locks will slowly lower it until it returns to Pacific sea level. But before continuing the journey, it's worth remembering the human cost required for this marvel to exist. The history of the canal begins in 1880, when France attempted to build it, facing landslides, torrential rains, and an invisible enemy, tropical diseases like malaria and yellow fever. These epidemics claimed the lives of around 20,000 people, turning the project into a monumental failure. Decades later, the United States took over the endeavor with a completely different strategy. Instead of excavating down to sea level, they decided to climb the terrain, carve through mountains, and lift ships using water. This time, they managed to finish the project, but at the cost of another 5,000 human lives. The canal is a technical feat, yes, but also a reminder of resilience and sacrifice. After advancing about 11 kilometers from the Caribbean entrance, the ship reaches the decisive point, the Gatun Dam and Gatun Locks. There begins the most complex challenge of the entire journey. The 3 interconnected chambers will lift the vessel to the level of the lake. Panamax ships, with their 300-meter length, barely fit inside the 320-meter locks, leaving a margin for maneuvering that is almost symbolic. Their 66,000-ton load makes every movement even more delicate. From the bridge, the pilots observe the bow stretching more than 220 meters ahead, greatly complicating depth and distance perception. Just parking inside the lock can take a full half hour. To achieve this, the ship relies on tugboats specifically designed to push and align it with surgical precision. Once inside the chamber, the most delicate part begins, securing the steel cables. These ropes are 2.5 centimeters in diameter that connect to 50-ton locomotives known as mules. These machines don't pull the ship, they keep it perfectly centered, controlling every centimeter of movement to prevent it from touching the walls. Each mule can pull up to 32 tons and costs around $2 million. The lock is 33.5 meters wide. The ship occupies approximately 32. That means that at best, less than 1 meter remains free on each side, a margin so narrow that any deviation could cause severe damage both to the canal structure and the vessel itself, completely halting traffic. For that reason, the mules constantly adjust cable tension, anticipating the current, the wind, and any unexpected movement of the ship. They guide it with a delicacy that contrasts with their size, keeping it so perfectly centered that, from above, it seems to glide along an invisible rail. When the ship is perfectly aligned inside the chamber, separated from the concrete walls by only a few centimeters, one of the most delicate and tense moments of the entire operation begins. The operator in charge, positioned in a control tower with full visibility of the enclosure, initiates the maneuver that marks the point of no return, the closing of the enormous gates that separate it from the Caribbean Sea. These gates are not simple metal panels. They are giants of steel and rivets, more than 2 meters thick. True articulated walls capable of resisting pressures that would crush any conventional structure. Their design allows no failure. They must withstand millions of liters of water pushing against them from the other side and still remain immovable, sealed, without allowing even a perceptible leak. When they close, they do so with an almost solemn slowness, as if each movement were aware of the critical role it plays in the safety of the ship, the crew, and the entire operation. Once the gates are firmly locked, the next step comes into play. Technicians open the main valves that connect the chamber to Gatun Lake. Then gravity takes command. There are no giant pumps driving the water. Everything happens through pure hydraulic engineering. The lake's fresh water descends through a hidden network of underground conduits, tunnels, and galleries that run beneath the chamber floor like a monumental circulatory system, invisible to the human eye. The rising water level must be perfectly controlled. If the water were to enter too violently, the turbulence could push the ship against the walls or subject the steel cables to dangerous tension. These cables, which look like simple metal ropes, contain such brutal force that if one of them were to snap, it would whip out with enough power to dent steel or instantly kill anyone in its path. Synchronization between valves, operators, mules, and pilots must be absolute. In just 8 minutes, a sigh in navigation time, but an eternity for those supervising the maneuver, nearly 80 million liters of water fill the chamber. The ship, which moments before rested at sea level, now floats about 8 meters higher, as if an invisible hand had gently lifted it. When the chamber reaches the exact height, the electric locomotives, the famous mules, move along their side rails to reposition themselves at the next lock. At the same time, the nearly 700-ton gates begin to open with calculated slowness, releasing a passage that marks the beginning of a new stage. But there is still much to climb. About 18 meters of elevation remain before reaching the level of Gatun Lake. So the mules continue their work, guiding the vessel into the intermediate chamber. There, the same cycle is repeated exactly: closing, flooding, lifting, opening. A mechanical choreography that appears simple from the outside, but is the result of more than 100 years of refinement. When the third chamber finally completes its cycle, the ship reaches the surface of the lake, located 26 meters above the Atlantic. At that point, the mules release the cables, and the vessel is once again on its own, ready to move unassisted into open waters. The first phase of its journey through the Panama Canal comes to an end, but the clock keeps ticking. It is already 1 in the afternoon, and only about 5 hours of daylight remain to cross the narrowest sections. If it doesn't make it before nightfall, it could delay the entire line of vessels scheduled for the next day. Gatun Lake, the next major stage of the journey, is a monstrosity in engineering terms. With its 431 square kilometers of surface, it was once the largest artificial lake on the planet. To put it in perspective, it is almost 3 times larger than Lake Como in Italy. And it does not exist for aesthetics or by accident. It is the central piece of the system. Without it, nothing would work. Each time the locks are operated, whether to lift or lower ships, around 200 million liters of water are consumed. On days of intense operation, when up to 40 ships complete the crossing, the system can expend more than 7.5 billion liters in just 24 hours. This aquatic colossus was born after the construction of the Gatun Dam, a titanic structure made from about 27 million tons of compacted material. It was built over the Chagres River, the true lifeline of the canal. This river constantly feeds the lake, replenishing the enormous amount of water lost with each transit. Without the flow of the Chagres, the Panama Canal would be literally unviable. On one side of the dam, a hydroelectric plant was also installed, essential for generating the energy needed to keep the entire system running without interruption. After 5 hours of relatively calm navigation across the lake, the ship approaches the southern end. But the calm ends abruptly. The most intimidating stretch of the entire route is approaching, the legendary Culebra Cut. This narrow, winding section, surrounded by unstable hills, was the greatest headache of the entire canal construction. Opening this corridor meant demolishing entire mountains with dynamite, removing millions of tons of rock, and facing constant landslides caused by rain and by the very composition of the terrain. The most famous explosion opened an 18-meter breach in the Gamboa dike and forced thousands of workers to remove rock day and night. For years, not a single week went by without a landslide. But finally, after a monumental effort and thousands of hands working without rest, they managed to excavate the 13 kilometers that now form the Culebra Cut. When the lake's water flooded the entire corridor, the dream of connecting both oceans for the first time became a reality. The ship now travels through this narrow passage for nearly 3 hours. Each curve requires millimetric adjustments. Every meter demands total concentration. There is no room for error. When it finally exits the Culebra Cut, the clock shows just past 4 in the afternoon. The light is beginning to fade, and 2 lock complexes still remain. Then comes the turn of the Pedro Miguel locks, and further ahead, those of Miraflores. These chambers operate under the same principle as those in Gatun, but in reverse. Instead of lifting the ship, they gradually lower it until it returns to the level of the Pacific Ocean. Each descent is one step closer to the final exit. The water drains from the chamber as if the lake were exhaling outward, lowering the ship with an almost hypnotic smoothness. The gates open and the process repeats until the full 26-meter drop is completed. And so, about 8 hours after entering the canal from the Atlantic, the ship finally emerges into the vastness of the Pacific. It has completed a journey that just a century ago required sailing around the southern tip of the American continent for an additional 2 weeks. Today, thanks to this engineering marvel, that same passage is completed in a single afternoon.